We are going to use both slope-intercept form and point-slope form today. First, we are going to use slope-intercept form. So when it says write your answer in slope-intercept form, that means y equals mx plus b. So in number 1, write an equation of the line that has the given slope and y-intercept. Notice they're giving us m, they're giving us b. So y equals 3x, and you can either write plus a -6 or -6. I was trying to make that problem like super hard. Can you hear the sarcasm? What is going on over there? Okay, in example 2, we need to write an equation of the line passing through the given points, and we're going to write our answer in slope-intercept form. That means our answer needs to look like y equals mx plus b. But to help us, we are going to use, I want you to write up here, point-slope form. This equation right here is called point-slope form. And I'm going to write it so it's just a little bit easier to read. Y minus y1 equals m times x minus x1. In slope-intercept form, we plug numbers into the m and the b. In point-slope form, we plug numbers into y1, m, and x1. Point-slope form is called point-slope form because it uses a point, x1, y1, and the slope, m. So we have to have the slope in order to do anything. So in this example, our first step is to find the slope. The slope formula is still written on the board in several places. Remember, you subtract your y's first. So 4 minus a -1. On the bottom, you subtract your x's. 3 minus a -2. 4 minus a -1 is 5. And 3 minus a -2 is 5. 5 divided by 5 is 1. So our m is 1. Your second step is going to be to plug this information into point-slope form. So we're going to have to pick one of these points. Should we pick the point that has a bunch of negatives, or should we pick the point that's positives? Positives. So we're going to take this 3, 4. 3 will be our x1, 4 will be our y1. So following point-slope form here on the top of the page, y minus the y value 4 equals m, so 1, and then x minus the x value 3. Next, we need to simplify and get this to look like y equals mx plus b. They want our answer to be in slope-intercept form. So we need to get this y by itself. First thing we're going to do is to distribute. In this example, it's not really that big of a deal because we're distributing a 1. But then we would add 4 to both sides to get y by itself. So y equals 1x plus 1. Okay, you do not need to put the 1 in front of the x, but you certainly can. So in example 3, first step, we need to find our slope. I want you to try this example on your own. Find your slope, write it into point-slope form, get it into y equals mx plus b. Okay, so our slope is -2. When we plug that into our formula, we would do y minus, and it depends which point you pick. It does not matter which point you pick. I'm going to use 1 and 6. If you used 3 and 2, you will still end up with the same answer, assuming you did all of your math correctly. So y minus 6 equals -2 times x minus 1. We would start by distributing into the parentheses, so -2x plus 2, and then add 6 to both sides to make this look like y equals mx plus b. Our answer is negative 2x plus 8. Y equals negative 2x plus 8. Okay, the next one, we need to start by finding our slope. 15 minus 8 over 5 minus 5. On the top we have 7, on the bottom 0. What is 7 divided by 0? Can't do it, it's undefined. This is where that Hoy and Vux thing can be really helpful. Undefined, that would be a u from Vux. So that means this equation is going to be x equals something with no y. X equals, take a look at both of your points. What's the x value in both of your points? 5. X equals 5. Okay, number 5 and 6, we're going to do a little bit differently. We're going to start the same way. Find our slope, or in this case, our slope is given to us. Plug the information into point slope form. Get it into slope-intercept form, y equals mx plus b. But then we have to go a little bit farther because it says write your answer in standard form. ax plus by equals c. That's a number times x plus a number times y equals a number. The important thing here is there has to be no fractions or decimals, and a must be positive. So the number in front of x must be positive. Now, we don't have to find the slope. This time they gave it to us. So our first step is going to be to plug this into point slope form. Y minus, what do I plug in next? Negative 3. This is a common error. If your point has a negative, you have to do minus a negative. Our slope is 5, x minus a negative 2. Now, what does minus a negative become? It becomes addition. So you can change those to addition. That's just point slope form. Now we distribute. So step 2 is going to be to distribute. We still have y plus 3 on the left. On the right, we would have 5x plus 10. Ultimately, we want it to be x and y on the same side and the numbers all on the right side. So we're still going to subtract 3 on both sides. Once we have it in this form, y equals 5x plus 7, if they wanted the answer in slope-intercept form, we'd be done. But they don't want it in slope-intercept form, they want it in standard form. So we need to move the x to the other side. Well, we can't just move stuff in math. We have to mathematically move it by subtracting 5x on both sides. So we have negative 5x plus y equals 7. Does anybody see a problem with that answer? It's got to be positive. We can't have negative numbers at the front of standard form. So we can multiply everything by negative 1, or divide everything by negative 1, or simply flip every single sign. So instead of negative 5x, we will write 5x. Instead of plus y, we'll write minus y. And instead of positive 7, we write negative 7. Okay, I want you to get started on number 6 on your own, and I will help you with the last step because there's something a little bit weird about the last step. So give number 6 a try on your own, and we'll pick it up here in a minute. So here's my point slope form. Y minus 4 equals 2/3 times x minus a negative 3. Now the minus a negative becomes a positive. So distribute, and this is where the fraction keys on your calculator can be very, very helpful. If you have a graphing calculator, just put 2/3 in parentheses. So 2/3 x, that's no big deal. 2/3 times 3 ends up being 2. It is. First, we need to get the y by itself and get all the numbers over to the right. So we're going to add 4 on both sides. That will give us y equals 2/3 x plus 6. Yes, we still have a fraction. We'll get there. The next step is to get the x over to the left side. So subtract 2/3 x on both sides. So we have negative 2/3 x plus y equals 6. This is looking like it's in the right order. Now we just have to address the negative and the fraction. To get rid of a denominator of 3, think about it like this. This is negative 2 divided by 3. How do you undo divided by 3? Multiply by 3. We are going to multiply every single term in here by 3. And then negative 3, because that will cancel out the negative in front of our x. So 3 times negative 2/3 is positive 2. Negative 3 times y is negative 3y. And negative 3 times 6 is negative 18. Now we have standard form with no fractions, no decimals, and our a value is positive. This is what your assignment looks like. This is 2.4 worksheet A, the bullseye worksheet. It's called the bullseye worksheet because it's a bullseye. So the center circle, 5, 2, you are going to be using the point 5, 2 for every single wedge of this circle. Each wedge is one problem with 3 parts. The first part is using the center circle and the inner ring. We need to write the equation in point-slope form in the outer ring. So you might want to jot down number 1 goes in the outer ring, and there's point-slope form. So get that written in on your paper. Number 2 is write the equation in slope-intercept form in the middle ring. So that's step 2, is simplify your point-slope form into slope-intercept form. And then your last step, the innermost ring, is going to be to rewrite your equation in standard form. So that's the same progression that we did in that last example. Start by writing it in slope-intercept or in point-slope form. Start by writing it in point-slope form. You might have to find your slope first, or in some wedges the slope might be given to you. It just depends. Write it in point-slope form, distributes, get it written in slope-intercept form in the next ring, and then the innermost ring, rewrite it in standard form. So we are going to try one. If you want to do this on the back, we're going to do this wedge together. Okay, Yep, we're going to use the point 5, 2 and the point 2/3, 2. In the next wedge, you would use the point 5, 2 and the slope negative 1/2. In the next wedge, you'd use those 2 points and so on. So you use the center dot for everything and then whatever is in that outer ring. It's on your paper.
Where?
Oh. Step number 1 for this problem, we have the point 5, 2 and 2/3, 2. We need to find our slope. So subtract your y's, 2 minus 2 on the top. Subtract your x's, 5 minus 2/3 on the bottom. And you might think 5 minus 2/3, that's really mean. But what do you notice about the top? 0. So I don't even care what 5 minus 2/3 is, because 0 divided by anything is 0. So we're going to write this in point-slope form. M is 0. Let's play along. We're going to use the point 5, 2. Y minus 2, that's the y value of that point, equals our slope of 0 times x minus the x value of the point. So that's point-slope form. If your slope is 0, you can write it in point-slope or in point-slope form. If your slope is undefined, you would not be able to write it in point-slope form. You would simply have to write x equals whatever. The next one, y equals mx plus b. What happens when we distribute 0 into the parentheses? You get 0. So y minus 2 equals 0. So you'd rewrite that with y on one side, y equals 2. doesn't look like y equals mx plus b, but it is, sort of.